Daksha Datta, and today I am going to present my second project of machine learning internship at Mentorness. This task is based on gold price prediction using machine learning techniques. Machine learning can be used to make predictions by training a model on a lot of data. In this project, I had to use machine learning on gold price data given to me, and the project objectives are as follows: time series analysis, advanced modeling, trading strategy development, market sentiment analysis, and statistical analysis. So the problem statement is as follows. This project aims to leverage a comprehensive dataset of daily gold prices spanning from January 19, 2014 to January 22, 2024, obtained from NASDAQ. The dataset encompasses key financial metrics for each trading day, including the opening and closing prices, trading volume, as well as the highest and lowest prices recorded during the day. The dataset description is as follows. We have the following columns: the date, a unique identifier for each trading day; close, this is the closing price of gold on the respective date; the volume, gold trading volume on the corresponding date; open, which is the opening price of gold on the respective date; high, the highest recorded price of gold during the trading day; and low, the lowest price recorded for gold in the trading day. The first objective is time series analysis. In time series analysis, we use statistical models to understand and predict the patterns in sequential data collected over time. For example, the gold price data that we have collected from NASDAQ. It involves analyzing data points ordered chronologically to identify trends, seasonality, and other patterns. By studying historical data such as stock prices, weather conditions, or sales figures, time series analysis helps forecast future values and make informed decisions. In this objective, I had to explore historical trends and patterns in gold prices over specified time period, and also identify seasonality, cyclicality, and any discernible long-term trends in the gold market. The code for the following is shown here. So I have imported all the necessary libraries and imported the data as well. We inspect the data using head, info, etc. commands. Then, to make sure that the data set can be analyzed properly, I have to remove any null values. So I check for any null values. Then I also delete the unnamed zero column so that we can easily analyze the data set. Here I have plotted the dataset over the date period. So we can see that the price of gold generally is tending to decrease as time goes on. I have also modeled an ACF plot, which is an autocorrection function. ACF, or autocorrection function plot, is a statistical technique that we can use to identify how correlated the values in a time series are with each other. The ACF plots the correlation coefficient against the lag, which is measured in terms of a number of periods or units. I import the augmented decay fuller ADF test function from the StatTools module of the statmodels.tsa library. The ADF test is a statistical test used to determine whether a time series is stationary or not. Next, the ADF test is applied to the high column of the data frame, and we are returned with a tuple containing various statistics and test results. The result is assigned the tuple returned by the ADF test. Then we also print the p-value associated with the ADF test. The p-value is used to determine the significance of the ADF test. A small p-value, typically less than 0.05, suggests stronger evidence against the null hypothesis or of non-stationarity. Then we also print the critical value for different significant levels of the ADF test. These critical values are used to determine the rejection region for the null hypothesis based on the chosen significance level. If statistic is lower than the critical value, we can reject the null hypothesis of non-stationarity. Then I have plotted the difference versus the original. I have also calculated moving average and plotted that in this plot. The second project objective is advanced modeling. Advanced modeling in machine learning refers to the utilization of sophisticated algorithms and techniques to solve complex problems and extract deeper insights from the data. It involves going beyond basic models like linear regression or decision trees to employ more intricate methods such as deep learning, ensemble learning, and reinforcement learning. Advanced modeling aims to handle high-dimensional data, capture nonlinear relationships, and deal with unstructured data like images or text. So the project objective of advanced modeling required me to develop predictive models to forecast future gold prices based on the historical data provided, and I also had to evaluate and compare the performance of different forecasting algorithms. The code for the same is as follows. First, I had to deal with the missing values, and I also calculated a correlation matrix. We can see the correlation matrix as follows. This matrix signifies the relationship of all the features. The closer the value is to 1 means a high relationship, and -1 means a negative relationship, whereas 0 means no relationship at all. Then for the model training, I split the data into features and target. Then I print the result as well. Then I create my first model. For this model, I use linear regression from the library sklearn. Then I predict the predictions and I calculate the r-squared error for the same. Error value of 0.099 is a very good indication that our model has made very good predictions. The second model I tried was random forest regressor, again imported from the sklearn library. I train the model and fit it on the data provided, then make predictions. I use the r-squared test again to test the accuracy of this model. A value of 0.099 again shows that the model has made very accurate predictions. I also compare the predicted values with the actual values and plot them on this graph. As you can see, the predicted values are very close to the actual values of our dataset. The next objective is trading strategy development. Trading strategy development involves creating a set of rules or guidelines for buying and selling financial assets such as stocks or currencies in the market. These strategies aim to capitalize on market inefficiencies, trends, or patterns to generate returns. Trading strategies can range from simple to complex, and they often require backtesting and optimization to validate their effectiveness before implementation. So I had to formulate and backtest trading strategies based on the provided price and volume information. I also had to explore the feasibility of reverse trading strategies for profit maximization. The code for that is given as follows. I import the backtrader library, which is a popular Python framework for backtesting and trading strategies development. Then I import the datetime module, which provides classes for manipulating dates and times. Then I define new class named mean reversion strategy, which inherits from pt.strategy class provided by the backtracker library. This class contains the logic for our trading strategy. The next lines define parameters for our trading strategy. These parameters can be adjusted to customize the behavior of our strategy. Then, the constructor method for mean reversion strategy class is defined. This method is called when an instance of the class is created. The lines followed by that calculate the relative strength index, the RSI, over a specified period of time using the relative strength index indicator provided by the backtrader. Then the method as follows calls for each new trading bar. The reverse strength index is calculated over a specific period. And the next method of the mean reversion strategy class is defined for each new trading bar. The trading logic of the strategy is contained in the following lines. If the closing price is above the moving average and the RSI is above the overbought threshold, it sells in this particular trading strategy. And if the closing price is below the moving average and the RSI is below the overall threshold, then it buys. The rest of the code involves loading historical data, creating a backtrader data feed, defining the trading strategy, setting initial cash amount and commission, running the strategy, printing starting and ending portfolio values, and plotting the strategy results using backtrader's built-in plotting capabilities. The next project objective is market sentiment analysis. Market sentiment analysis involves gauging the overall mood or attitude of investors and traders towards a particular financial market or asset. It assesses whether market participants feel positive, negative, or neutral about future price movements based on factors like news, social media, or economic indicators. In this task, I had to investigate the impact of market events on gold prices. I also had to assess market sentiment and its influence on short-term and long-term price movements. The code for that is as follows. I import all the necessary libraries and I use a new dataset for this which has price sentiment already labeled for all the data present. Then I load the data and I make a few changes in the columns. I also investigate the data using shape, info, etc. and check for any null values. Then I plot that data as follows. Based on the analysis, we can see the negative, positive, and none, as well as the neutral sentiments of the data provided. This is also shown in the form of a pie chart. The overall conclusion is that there are more positive than negative sentiments, and there are very less neutral sentiments as well. The last project objective is statistical analysis. Statistical analysis involves the process of collecting, organizing, and interpreting data to uncover patterns, relationships, and insights. It uses mathematical models and techniques to summarize and analyze data, helping to draw conclusions and make informed decisions. Statistical analysis can include measures such as mean, median, and standard deviation to describe data distributions, as well as hypothesis testing and regression analysis to explore relationships between variables. I had to conduct statistical tests and analyze to gain insights into the characteristics of gold price movements. I also had to explore correlations with external factors and macroeconomic indicators. The code for the same is given as follows. I import all the necessary libraries and once again I make a plot of the gold price movements in which gold price is plotted against the date. Next, I perform time series analysis using autocorrection function and partial autocorrection function on the close prices of gold data. The autocorrection function for the close prices of gold data is calculated, and then the number of lags are included in the ACF calculation, which is set to 40 in this case. Then the partial autocorrection function is calculated for the close prices of gold. The parameters are specified for including the number of lags, which is also set to 40. Then that is plotted against each other. The ACF and the PACF plots are indicated as below. Then I conduct descriptive analysis. Descriptive analysis involves summarizing and describing the main features of the dataset, such as its central tendency, dispersion, and distribution. It provides insights into the basic characteristics of the data, allowing researchers to understand its structure and make initial interpretations without performing any complex statistical tests. So the descriptive statistics includes calculation of mean, standard deviation, min, max, etc. for the close prices of gold data using the describe function, and stores the summary in stats summary variable. All the calculated values are shown as below. Then we have also created a plot to visualize the gold price data along with the rolling mean and the rolling standard deviation. It uses matplotlib to plot the gold price, the rolling mean, and the rolling standard deviation. And we've also added labels, titles, and the legend for the plot. I have next included all the references in the code as well as the PPT. This concludes my presentation of my second project of Mentorness internship opportunity. I am very thankful for this opportunity and I look forward to working on other projects as well. Thank you for watching.